So I'm Damien Moal with Western Digital and managing the sister software group within Western Digital Research. And so with the start of this hybrid SMR standardization effort, we have started looking into how that would be supported in Linux, and this is the topic of this presentation. So I'll go quickly, since Ted just talked about hybrid SMR and how it's going to look like. I'll go quickly through the first introduction, talk about the kernel support and all the ecosystem also that we have built on top of that for SMR support. So hybrid SMR. If you look at a regular on the top right side there, regular SMR disk, what you see from the host is a single LBS space that exactly corresponds to the physical capacity of the disk. With that LBS space generally being split into a portion of CMR, randomly writable space, and SMR space that has to be sequentially written. With hybrid SMR disk, as Ted described, you also get this split into the the LBS space seen by the host. But the major difference with the normal ZBC, ZSE SMR drive is that the LBS space is much larger than the actual physical capacity of the disk. So very similar to a scene provision read array, for example. Not LBAs are directly usable. And the reason is that we want to be able, as Ted described, to convert the drive between being CMR compatible, randomly writable, to SMR to gain capacity. And so this is here explained here. So host hybrid SMR devices are very similar to regular SMR drives. The LBS space is fully described by zones, the 256 megabyte being the most common value. So each of the space, CMR and SMR, are split into zones, but not all zones within those spaces are provisioned physically. They may not have any physical sector associated. So in the standard, we're talking about active versus inactive conditions for those zones. So in this example here, the beginning of the CMR LBS space has some active zones, then followed by some inactive zones. And those inactive zones, they do not use any physical storage on the device. That physical storage can be used on the SMR LBS space. Here, the last zone of that space are being active and using that physical space. So as you can see here, by changing the state of zones between inactive and active, you can actually move the provisioning, the physical storage provided by the disk, either fully toward the CMR LBS space or the SMR LBS space, or any combination of the two. This is the principle that is used in those hybrid SMR drives to switch between high IOPS, randomly writable, fully compatible, regular type of use of the drive to a higher capacity SMR drive. So the standard, this is ongoing work, as was mentioned in the previous presentation. But here some highlights of the points that are still being discussed, but that kind of everybody agree on at this point, is that, first of all, a hybrid SMR drive will have a device type, the same device type as regular block device, so device type 0, so that when you have the drive fully provisioned into the CMR LBS space, you can actually use it as a regular drive without any special driver being needed. 3 new commands, 2 or 3, this is still being discussed, are going to be defined for this new standard. One allowing to do the conversion, so here it's named media convert, the name is not fixed. So this command will allow doing the activation and inactivation of zones within the LBS spaces, and 1 or 2 commands to allow you to determine what zones can be activated or deactivated. And if you want, for example, to activate some zones in the SMR LBS space, what are the zones that you need to deactivate in the CMR LBS space? Since there's the same physical space cannot be used for both LBS spaces, you need to know what the impact of an activation is going to be, and these commands will allow the host to discover that. Regarding the zone information, there's not much changes from the regular ZBC standards. There is a zone report command that will give you zone types. Those types are constant. They do not change, but the zone condition, there is also a zone condition, a condition associated to all zones. These are what changes depending on the use of the zone, and the new active or inactive condition are going to be added there. Also, for the SMR part of the LBS space, there is mostly, I think, 0 changes from the regular ZBC standard. And as I said, this new inactive or active, I don't know which one we're going to add, new conditions are going to be added to describe the physical storage association of zones. Another part that is still actively being discussed in the standard is how are we going to handle conventional zones. And the reason for that is that as you convert from some SMR space back to CMR, you're basically changing the physical format of the drive. You have to unshingle the tracks. And to do that, physically, the drive normally has to do a first write pass, rewrite the tracks, so that information for seek can be laid down on the media, and the space become fully randomly writable. The problem to do that, we need to physically write on the media, and that can take time. So one thing that we want to add to the standard is a very fast conversion pass, where you just change basically from SMR to CMR without doing that reformat. And you allow the host to do that first sequential write pass to reformat the drive while storing data. This is an optimization. Either you do zero field the zone, or you can optimize writing sequentially your data that you can then randomly update. So, two possibilities. The drive does this initial formatting for you, but as I said, that can take time. Or you give the host the option to do it itself to optimize its usage of the drive. And the important point here is that having only the option for the host to do the initialization itself would basically somewhat break the backward compatibility with ZBC, the current ZBC, because with ZBC you do not have this constraint of having to first write sequentially conventional zones. You can, out of the box, write those zones randomly. So both possibilities may end up being added to the standards. This is something we are currently discussing. Again, here, this is important for all potential users to give their opinion so that we can gather use case and end up with the standard in a form that is most useful to everybody. So here is the summary for the differences between regular ZBC, ZSC, host managed SMR, and hybrid SMR. So device type changes. 014 for host managed SMR becomes regular 0 block device type for hybrid SMR. LBS space, in both cases, is fully described with zones, but we do add new zone condition for hybrid SMR. And most likely, most of the difference between the two are also going to be centered around how we handle conventional zones. And as I said, we are still discussing this. But we may introduce a new conventional zone type for that case where the host wants to optimize that first initial write pass itself, and also preserve the ZBC-defined conventional zone type to get backward compatibility with ZBC. So now, Linux kernel. Over the last 2-3 years, we've built added many pieces to the kernel to support SMR. We needed to add some constraint on the drive within the kernel. Those constraints are here. All the zones must be the same size. The zone size must be a power of 2 number of LBAs, and reads to sequential zones must be unrestricted. These are the 3 main conditions put on the drive, and hopefully all the drives on the market today have no problem with this constraint. They all follow these characteristics. Most of the work was centered around the ability to sequentially write, to ensure sequential writes are delivered in that same order to the drive. There are many places in the kernel and also the actual physical I/O paths to the device where reordering of writes can happen. And of course, that would result in I/O errors for SMR drives, and the same on hybrid SMR2. So a lot of work has been done around the I/O path to ensure sequential writes. This is all operational today. It is in stable release of the kernel. So for the hybrid SMR, the new hybrid SMR standards, what we are planning to do is, well, to reuse as much as possible of that SMR support in place. But first things first, device scan at boot time or on hot plug. We will need to change that because of the change to the device type. And we also need to recognize the fact that the drive has this new feature set, hybrid SMR. All the zone size constraint we have in place will remain. This is necessary for the I/O path within the kernel. But there is no plan to change any of that on the actual devices themselves. We are still going to use power of 2 zone sizes, 256 megabytes, again being the most common value for zone size. So that sequential write constraint we have put in place is implemented using zone write locking. And we are planning to reuse that too. Of course, for the sequential zones part of the LBA space of hybrid SMR drives, but also eventually, potentially for these new conventional zones that need that first initial write pass to reformat the drive. We can reuse that zone write locking mechanism to ensure that this initial first sequential write pass of conventional zone is successful. As I said, we have also put into the kernel many other components to enrich the SMR ecosystem. So, for example, many changes were added to the device mapper infrastructure within the kernel. We also added a new device mapper, an entire new device mapper driver called DMZoned, which allows to expose a host managed drive as a regular block device, so that you can use even an SMR unfriendly file system on top of those devices. So this is an actual very good candidate for supporting hybrid SMR drives, as it has the capability to remap zones that you would be, for example, converting between SMR and CMR on a hybrid SMR drive. We also have added native support within the F2FS file system. Most of that support will still be valid for hybrid SMR drive, but there is still a catch here, is that F2FS has a hard limit of 16 terabyte on volume size, which is going to be too small for hybrid SMR drives. So initially, at least, you can avoid that problem by using, for example, device mapper, DM linear, and chunk the drive into small portions. But eventually, changing F2FS to support larger than 16 terabyte LBA space will be necessary. We also have better FS support for SMR running in the lab. We still need to upstream that. But again, most of that support will be valid for hybrid SMR drives with only a few changes. On the other higher level, so user level tools, so we are maintaining this libzbc library for SMR, and we plan to add hybrid SMR support within that library. So basically add APIs for the new commands that the hybrid SMR standard will define. So media conversion, media query for knowing how to activate and inactivate zones. Also, initially, I forgot to mention, it's written in the slides, but I forgot to mention it. There is no really strong use case for implementing within the kernel support for those media conversion commands. Because at least initially, there's likely going to be no kernel internal user for those commands. So here, libzbc or SG3 utils will be providing support for the conversion. So at application level. We also have recently released an SMR ZBC emulation handler for the TCMU, so SCSI target user level emulation for the TCMU runner project. And we are planning also on releasing the same kind of emulation handler for hybrid SMR drives. So this is an excellent tool for debugging application because you do not actually have to, for example, get a bus trace to know what's wrong with your IO pass. You can directly pick at that application and then get the IO order and what's going on between your application and the device. And it's so both an excellent tool for debugging application as well as the kernel, which is the reason initially we are going to release it, because this is our main tool for debugging in a very convenient way the kernel IO pass. And I'm, 38 seconds remaining. I'm on time. So to get involved more with hybrid SMR, so OCP storage group has, as Ted mentioned, is starting activities on hybrid SMR. There is a bi-weekly call? No, monthly or bi-weekly? Huh? Monthly call, yes. I never actually joined, but monthly call. We also have, I live in Japan, I'm not the same time zone, so. And Ted mentioned next week, Monday, we also have another T13 meeting on hybrid SMR, so please join and let your view be heard there so that we end up with a very good standard for everybody. And this is the end of my presentation. Any question?
Okay, questions. We actually have now a 20-minute session for discussions on this topic. Before I go on to questions, let me just mention, because I get this question a fair bit, if you guys are discussing this in T10, T13, so why do you have a parallel track in OCP? And what happens is often when you go into interface standards, you're going to define the command behavior, and how to describe fields of capabilities. What's happening within OCP and the cloud optimized HDD work streams is trying to figure out what are parameters or things that go beyond just what's in the command spec that are required for these data center applications. And these are things that you wouldn't put in the interface specification itself. So an example might be, hey, we want those SMR zones to be powers of 2 in size. Initially, actually, some of the vendors had proposed that to be in the standard, and the standard said, no, we want a flexible design in the specification, and that's something that a vendor unique would decide or a product requirements would decide. But these kind of capabilities and parameters and frameworks are the type of things that you can put in within the OCP framework of for this use case, this is what I would need those parameters or those settings for the devices to be. So in the past, there has been a lot of, a standard comes out, and then after the fact, you have a discussion of how to set the parameters. And sometimes you find out, oh, if I don't have enough flexibility in what was standardized to use for my use case. And then we iterate. So what's happening here is we're trying to get a little bit ahead of the curve and do the use case development together with the standards to make sure that we have the standards flexible enough to cover the use case, and simultaneously we have what is that the vendors ought to build to fit that use case in particular. Is that clear? Awesome. Number two is you can go to the OCP storage wiki and you get all the information about the calls. For the T13 study group, it's not there right now, but I'll post information about where you can find it and meeting locations, etc. Cool. With that.
One of the slides I saw that Linux will support hybrid SMR drives by serializing writes even for conventional zones.
Yes.
Will that result in optimal performance?
No. Okay, so this is the tricky part since the standard is not well defined in that area yet. So I can only talk about possibilities at this point. But so what we can do is, so we have to, so that new fast conversion leads to a conventional zones where you have to write at the right pointer or below. Basically, essentially, you have to have a first sequential write pass to reformat the media. And that, in essence, requires that you ensure that sequential writing. And so you end up with the same constraint as a normal sequential write record zone. So you need zone write locking. So that is suboptimal because you cannot write at high Q depths until you fulfill that first full write pass of the zone. Now the trick is how do we now disable the zone write locking once we know that we have fully written the zone. This is the tricky part and not clear yet. I don't think I'll have a clear answer until we fix the standard. So as new methods are being proposed, every single one I go through them and think of the actual implementation and weight the good points, bad points from the support perspective to see how hard or easy that optimization become. But this is currently the main concern, especially when you convert your drive, which has, let's say, a fair chunk of SMR LBAs activated, you convert everything back to CMR. Then you end up with a drive where all the zones, you can only have one single outstanding write per zone at any time, but you want to use that drive in a fully CMR compatible mode. So this is not really performance-wise compatible with CMR, with a regular drive, so we need to do something there. We'll come up with something.
Anyone? Anything?
Could you talk more about the motivation for the power of 2? Is it host address translation?
No, this is simply arithmetic, bit shift, no divisions. There's no 64-bit divisions in the kernel. It is basically reusing the software read mechanism of stride chunking on disks. It was code that was already in place in the kernel. And it also is needed because the standard has constraints also on I/O alignment. You cannot span zones. For example, for the sequential write required zones, you cannot span writes. Writes have to be fully within a zone. But the application may do something wrong, so you need to split I/Os between zones. And all that code for software read was there and doing that already, so we just reused it. And the constraint is, of course, you need to do that with bit shift and bit masks, so power of 2.